Electrolysis means simple. You will take a compound, and that compound we are taking in a molten state or in aqueous state. It undergoes decomposition after passing the electric current. That will be called as electrolysis. Basically, decomposition of a chemical compound in aqueous solution or molten state using direct electric current. So remember, electrolysis we use DC current, direct current, not AC. Alternate current we don't use. Okay. Then these substances which conduct electricity in aqueous solution or molten state, we call them as electrolytes. And if they do not conduct electricity in any state, like even if you take them in aqueous or molten state or liquid state, if they don't conduct electricity, we call them as non-electrolytes. Okay. So question comes here. Give reason question. NaCl conducts electricity when it is in the molten state or aqueous state. Aqueous matlab dissolved in water. Okay. But the same NaCl in the solid state do not conduct electricity. Ayona, can you tell me why? In which case? Okay. Why it conducts in molten or aqueous state? Right. So to conduct electricity, we need charged particles, and the charged particles should be able to move. So there are two things: one, the electrons or the ions. Anyway, the solid compounds will not contain free electrons or free ions. Okay. Therefore, we take them in the molten state or aqueous state where they will have free ions and they will conduct the electricity. Whereas you compare it with the metallic conductors will have free electrons. Okay. And non-electrolytes will never conduct electricity. The reason being they don't have any ions. In whatever state you take them, they will not have any ions. Therefore, electrolytes will contain ions. Non-electrolytes will contain only molecules. Non-electrolytes. Some examples of non-electrolyte: alcohol, distilled water, kerosene, urea, carbon disulfide, glucose, or you dissolve sugar in water, sugar solution. That also does not conduct electricity. Okay. So these are the basic definitions of electrolysis, electrolyte, non-electrolyte. Okay, which of these will act as a non-electrolyte? Darshwana, can you tell me which one? Acetic acid, okay. What about liquid carbon tetrachloride? No, liquid. Liquid means not aqueous. Aqueous means you dissolve in water. Liquid means it's just changing into liquid state, right? So now tell me, CCl4 is what type of compound? What is the type of bond in it? Covalent. In that too, whether it is polar or non-polar. Non-polar because it has a symmetric structure, right? That's what we learned. The carbon chlorine bonds are polar, but because of its symmetric structure, overall molecule will be a non-polar, and non-polar molecules, and that too in a liquid state, do not conduct electricity, even, and it is also not soluble in water. Okay, so more specific or appropriate answer will be liquid carbon tetrachloride, or simply carbon tetrachloride. Also, they give you the same answer. Acetic acid can also be correct, but they have to mention here acetic acid solution, just like other things. Yeah, if you take it in aqueous state. Okay, yeah, but yes, acetic acid is also the state of matter is in liquid state. Okay, but it is an organic compound now. So when it dissolves in water, or polar compound it is. So when it dissolves in water, then only it conducts electricity. Okay, therefore that has to be solution state. Polar, covalent, last class chemical bonding. Polar covalent compounds conduct electricity only in aqueous state, like hydrochloric acid, right? Ammonia solution dissolved in water. If they are in the liquid state, they do not conduct electricity. They have to be dissolved in water. Give reasons why. Solid sodium chloride will conduct electricity only in fused or aqueous solution state. We just discussed it, right? So tell me, Rishi, why? What is the reason for this? So you have to write both the points. Like, it has free ions in fused or aqueous solution, therefore it conducts electricity. But in solid state, it has no free ions. Okay. Anyway, here they have just given in aqueous or fused, that much will be sufficient. Okay. Although copper is a good conductor of electricity, it is a non-electrolyte. Dhanesh, can you tell me what is the reason for this? Then why it is a good conductor of electricity? Right. That point we have to say. See, when we are talking copper, copper is a metal, right? It is not a compound, it is an element. Copper will conduct electricity, or metals do conduct electricity because of their mobile electrons. Means the electrons in them keep on moving from one atom to another atom. So in that process, they conduct the electricity. But why it is a non-electrolyte? Because it has no free ions. The particles responsible for conducting electricity are mobile electrons and not the ions. Hence, it's a non-electrolyte, but still it conducts the electricity. So this can also be, uh, asked as a name the following, right? A substance which is a good conductor of electricity, but it is a non-electrolyte. Then you can name any metal which conducts the electricity. Copper, aluminium, iron, anything. Identify the following. Okay. Vanishika, can you read and tell the answer? Right. Right. Any other example? HCl is correct. It may be HCl gas, it may be ammonia gas, because ammonia also, when any polar covalent compound which is in the gaseous state at room temperature. So whether you take HCl in gaseous state or in liquid state, or ammonia in gaseous state or liquid state, they do not conduct electricity in the pure. We call this as pure state, right? But when you dissolve in water, they make free ions, right? Okay. This one I explained initially, right? When the difference between metallic conductor and the electrolyte. Hmm. So the electrical conductivity of copper sulfate solution, copper metal. Copper sulfate solution is what? It is an electrolyte. So the electrical conductivity will be because of free ions. Okay, and copper metal, it's an element, right? So the free mobile electrons are responsible for carrying out the electricity. Okay. Tanisha, Tanisha is not here. Okay. Now, under electrolytes, we have two kinds of electrolytes, strong and weak electrolyte. This I have also explained during the acid basis salts. Strong acid, weak acid, they all are examples of strong electrolyte and weak electrolyte. Yeah. mobile electrons. Mobile means moving, okay, which are able to move freely. Strong electrolyte, weak electrolyte, the key term, completely dissociate. If it is an ionic compound, write completely dissociate. If it is a covalent, polar covalent compound, then you write completely ionizes. Only for polar covalent compound, it completely ionizes in aqueous solution. But for ionic compound can conduct electricity in aqueous as well as fused. Fused is nothing but molten state or liquid state. Therefore, they are very good conductors of electricity. Whereas weak electrolytes partially dissociate or ionize in water or infused state, hence they are poor conductors of electricity. Completely dissociate means more number of ions. More number of ions means the conductivity will be very high. Whereas weak electrolyte, they will be partially ionizing, they will have less number of ions. Hence their electrical conductivity will be there, but it will be poor. Say you have connected this to a bulb. So when you use a strong electrolyte, the bulb will glow brightly. But if you take weak electrolyte, the bulb will glow dim. It will be dim, not bright. Okay. Same way, you can also explain the strength of an acid. Why it is a strong acid, why it is a weak acid, based on number of H plus ions only. More number of H plus ions when you dissolve in HCl. Therefore, it is a strong acid. Completely ionizes. Why acetic acid is a weak acid? Because when it dissolves in water, it partially ionizes. Hence, less number of H plus. Right? Based on that only we have to explain. So some examples we can remember for strong and weak electrolytes. Okay. Now comes the particles present in strong electrolytes. Chanvi, can you tell me?
So it's mainly ions.
Very good. Can you tell me in which case it will be only molecules?
Only molecules is like when it's a non-electrolyte.
Very good. And when it's
A weak electrolyte is like ions and like molecules.
right, correct. Okay. So all the three kinds of particles we have seen here. Identify the weak electrolyte from the following. Aryan, tell me.
So can you hear me?
Yeah.
Uh, aqueous acetic acid.
Aqueous acetic acid. The aqueous solution of the following compounds which contains both ions and molecules. Dhruva?
Uh, so again, acetic acid.
Acetic acid only, yes. Because it is a weak electrolyte, so and weak electrolytes will have ions as well as molecules. Okay, so this is again what I just explained based on that. Here A, B, C are there connected to separate circuits. A contains sodium chloride solution. B contains okay, when the circuit is completed, bulb in the circuit glows brightly. Cell B contains acetic acid, and when it is connected to bulb, it will be dim. Electrolyte cell C contains sugar solution, bulb does not glow. Give a reason for each of these observations. So same thing you have to explain on. Sodium chloride is a strong electrolyte, completely dissociate in water, hence has more number of free ions. Therefore, bulb glows brightly. Okay. Whereas acetic acid is a weak electrolyte, less number of ions. Bulb glows dimly. Then lastly, sugar solution, that will be non-electrolyte. It has no free ions. Hence the bulb will not glow. Okay. Huh. This is the difference between the two terms, ionization and dissociation. Very simple. This has been asked many times, like name the following question. Okay. Ionization is the formation of positive and negative charged ions or cations and anions from molecules which are not initially in the ionic state. Which are those? Those are polar covalent compounds. So when you take HCl, HCl is a polar covalent compound and not has any ions. But the moment we dissolve it in water, it will split into ions. This process we call as ionization. Whereas dissociation is the simply separation of ions which are already present in the ionic compound. How do we know this? Whenever ionic compound forms, always it has cation and anion, but we don't write it. We simply write NaCl, we don't write Na plus Cl minus. But it is always cation and anion will form the ionic compound, and the moment you put it into water, these ions get separated, Na plus Cl minus. Therefore, it has a different term called as dissociation. Okay, ionic compounds show dissociation. So these are the two differences also. Okay, na? So use the proper term when you are explaining the reasons and all. Okay, now we will go to the examples of electrolysis. But before
So
that,
actually explain ionization dissociation.
ionization, if the polar covalent compound dissolves in water, that process will be ionization. Because polar covalent compounds are not in ionic
What
state initially.
ion?
Hmm.
What does it mean by initially in ionic state?
Not initially means HCl. In HCl, you don't have any ions initially. Just like in Na plus Cl minus, you already have ions. In ionic compounds, these are already ions, है ना? But they are not separate. But in HCl, there are no ions. They are simply atoms. Okay, that's the difference. Therefore, always where you use the word molecules you will use only for the covalent compounds. Do not use molecules word for the ionic compounds. Ionic compounds do not exist as molecules. Molecules only for covalent. Okay, basic terms about electrolysis. So electrolysis, to carry out electrolysis, we need to have one container. That container will be called as electrolytic cell. Electrolytic cell. Okay, and we need and we need something which conducts the electricity, that will be electrolyte, and electrolyte is what? In molten or aqueous state it should be. Then we will take two metallic conductors, metallic rods, or even it may be a graphite rod. Graphite is not metallic, hence it is named separately. Metallic rods or conductors which are immersed in the electrolyte, and these are connected with the help of wire to battery. Battery always gives you DC, direct current. The longer line will be plus or positive terminal, smaller line will be negative terminal. In some cases you will have multiple cells like this, but always it will end with one bigger line and one smaller line. So this will be plus, this will be minus. The one which is connected to positive terminal, that both of these are called as electrodes. So that positive terminal connected one is called as anode. The one which is connected to negative terminal, that is called as cathode. Okay, and how to remember anode is positive? A D, you can remember add. Some people may have difficulty now. So anode, in that you have add, therefore add means positive addition, right? Therefore that is positive, and cathode will be negative. Okay, one more mnemonic we will right here, CNR pow. What is the CNR pow? C matlab cathode, N means negative. This thing you can make note of. R means reduction. All electrolysis reactions are what? They all are redox reactions. Therefore, simultaneously oxidation reduction will be taking place. Which one is oxidizing electrode? Which one is reducing electrode? If they ask you, you should be able to write that. So this will help you that. P for positive, A for anode, okay, and O for oxidation. Means cathode is negatively charged, the reduction takes place. Anode is positively charged, oxidation takes place. So which one is oxidizing electrode? Anode. Which one is reducing electrode? Cathode. Many people lose marks for these kind of questions in MCQ. Okay. So if you remember this mnemonic, it will help you. And how to remember oxidation reduction? In this case, we write oxidation reduction with respect to loss or gain of electron. So you remember another mnemonic, oil rig. Oxidation is loss of electrons. Reduction is RIG. Reduction is gain of electron or electrons. Okay. Oxidation, reduction. So this much if you know, most of your things will become easy. Okay, now. So these are the basic things. And because anode is positive, in the electrolyte you will have positive and negative ions. So anions will move towards anode. Anions are negative. They will move towards anode. Cathode, cations will move towards cathode because cations are positive, because opposite charges attract each other. Okay. Now coming to the preferential discharge of cations and anions. So for that we know, we should remember the electrochemical series. Electrochemical series is actually the reactivity series for the metals. But when the metals form the ions, that if you write in the decreasing order of their, the same trend for whatever you write for the metals, the one which is lower, that will get discharged first. Okay. The tendency of the cation to discharge increases as you move down the list. So this is basically the list of the cations and anions and not actually the elements, not the metals and non-metals. Okay. So lower the position, faster it will get discharged at respective electrode. Similarly for anions, we have one list here. I gave you here a technique to remember the anions list. Positive anyway, whatever electrochemical series you remember, same thing only. Okay. But for negative, what you can do, fluoride will never get discharged. So that is on the top. Then remaining, S for suno and for no. Okay, suno, caliber, IO. Okay, suno, caliber, IO. So one which will get discharged faster, that is hydroxide in this case. Okay, na? And the one which get discharged faster among the positive one, silver ions. But if you're given the comparisons, you know which one has to be selected based on the list only. Okay, and other mnemonics I have given here only. So this is one thing. Another point which affects the preferential discharge is the nature of the electron. Nature of the electrode. I'm not talking cathode and anode. I'm talking about whether it is inert or active. Inert electrode means it will not take part in the reaction. But if it is active electrode, it actively takes part in the reaction. We have only two inert electrodes, graphite and platinum. And active electrodes will be any other metallic conductors, copper, silver, okay, any other metallic conductors, nickel, etc. Okay, now. So this will also decide the product. With example, we'll see in upcoming slides. Lastly, one more is there, that is concentration of ions. In this case, you know only one example. Okay, when you take dilute NaCl and when you take concentrated NaCl, both are aqueous state only, means dissolved in the water. But in the dilute NaCl, you will be having Na plus ion, Cl minus ion, and water will give you H plus, OH minus. Same thing for NaCl concentrated also, right? Na plus, Cl minus, H plus, OH minus. But in case of dilute, what happens? Na and Cl will be in less number because it is diluted state. Solute particles will be less. Solvent particles will be more. Solvent is water, so these particles will be more. So what happens? H plus and OH minus will go towards respective electrodes. H plus will go towards cathode and get discharged as hydrogen, and OH minus will go towards the anode and get discharged as oxygen. So basically, electrolysis of dilute NaCl, if you are doing, you are getting hydrogen and oxygen only. It is simply the electrolysis of water only. But in the second case, when you take concentrated NaCl, solute particles will be more. The concentration of Na plus and Cl minus will be more. But if you, now what we may think, so respectively, Na and Cl will get discharged. No, that will not happen. In this case, even though the concentration of Na plus is more, it is far, it is on the top of the list. See here, it's very less likely to undergo discharge compared to H plus. H plus is here. So there is a huge difference between the positions. So even though the concentration of Na plus is more, in this case also only H plus will go towards the cathode and hydrogen gas will be liberated. But what changes? The change will take place at the anode. We expect hydroxide to get discharged faster because it is below, right? Compared to chlorine is here, hydroxide is here. One second, let me finish. Okay, now. So Cl minus, because of its more concentration, that will overcome this preferential discharge and that will get discharged as chlorine gas. So when you do electrolysis of concentrated NaCl, what products we are getting? Hydrogen at the cathode, chlorine at the anode. You will never get sodium if you take aqueous. If you want to get sodium metal, you always have to take sodium chloride or sodium compound in the molten state only. If there is water in it, it will never get discharged. Okay? Yes, Danish, what is your doubt?
Yes, sir. Sir, for the NaCl part, is it there on textbook?
Yeah, it will be there. It has been asked previously also. Okay, so just keep one point, that is about this one. When there is
Sir,
a change. Yeah,
so Cl because it's more, the ion because it's more in quantity, it gets
yes.
discharged more
Preferentially,
before.
yes. Yes.
Okay.
Okay. So only this particular example only you remember. Don't worry about anything else. Hmm? But what I told you, sodium you will never get unless you take it in the fused state or molten state, because sodium is so reactive that if you take water and even though sodium forms at the respective electrode, it is immediately reacting with the water which is there in the electrolyte and again forms sodium ion. Therefore, we will never get sodium if there is water. Okay, so the kind of questions they have asked previously. An aqueous electrolyte consists of the ions mentioned in the list. The ion which could be discharged most readily during electrolysis, right? Rohani, tell me.
Yes, it's Cu.
Cu2 plus. Okay. Sometimes in the exam, what they do, instead of most readily, they will change the question to least readily. So you never just see a Fe, copper, lead, H is there. So copper should be correct. No, you have to read the question properly. Okay, similar kind of
Sir,
question.
least is Fe, right?
Least will be Fe, yes. Uh, the ion which is discharged at the anode during the electrolysis of copper sulfate solution using copper electrodes as anode and cathode. Tanisha, would you like to try? But preferentially, which one out of these two?
Perfect. Uh,
For that, you should refer the list.
it'll be SO4.
Mhm. SO4 is on the top. Okay, always hydroxide,
Oh yeah,
which is
sorry.
below, that will get discharged. Okay, Suno caliber IO. You can remember that Suno caliber IO. Okay, chalo. So the ion which will get discharged at the anode, both of them will go towards the anode, but preferentially hydroxide will get discharged. When dilute sodium chloride is electrolyzed using graphite electrodes, the cation is discharged at the cathode most readily. Mm, yes, Vanishika, tell me.
Um,
H plus. Okay, whenever H plus is there and sodium ion is there, it's always H plus. Whether it is dilute or concentrated doesn't matter. Okay, again similar kind of question here. Rishi,
Yes, sir.
what is the answer for this?
Yes.
Okay, you can mute. So solution which contains magnesium, iron, copper ions. On passing electric current through this solution, which ions will be the first to discharge? So that is copper. You know. Second part we will not see now. We'll see later. Okay, let's take the examples of electrolysis. We have three examples. The first example is the electrolysis of molten lead bromide. Remember, it is not aqueous, it is molten. Therefore, you have to keep on heating the substance till the reaction gets complete. So we have to keep the temperature 380 degrees Celsius. That is the melting point. So above the melting point we have to keep now. So we'll keep 380 degrees Celsius throughout the reaction. So here what we do this reaction in a silica crucible. Silica crucible is a white crucible like this. I think you might have seen in the lab. In this, we will take what kind of electrodes they are using? Graphite electrodes. So graphite is inert electrode, right? So you have to take both the graphite electrodes, anode and cathode, connected to the positive and negative. Which is connected to positive, that is anode, and connected to negative, that is cathode. What is the electrolyte? Molten. Do not write lead bromide. It is a molten lead bromide. If it is aqueous, then aqueous, but this is molten we are taking here. Molten lead bromide is the electrolyte. Now, one of the give reason questions they have asked previously, why silica crucible we are using here? Because silica crucible is non-reactive. It can withstand with high temperature and non-conductor of electricity. Okay, so because of these reasons, we use silica crucible. Why graphite we are using here? Okay, at the anode. Anode is this. Cathode is this. So when this reaction takes place, initially lead bromide is there. When you melt it, it will form lead ions and bromide ions, because there are two Br atoms, so it will form two bromide ions. Lead is cation, it will go towards the cathode because cathode is a negative, and bromide is a negative anion, it will go towards the anode, which is positive. Okay. Now, what happens at the cathode? CNR, reduction takes place. Reduction means gain of electrons. Pb will gain 2 electrons and become Pb atom. And Br, straight away you can take 2 Br, or you can take a Br minus first. 1 Br bromide ion loses 1 electron and becomes bromine atom. But bromine atom is not stable, therefore it has to, am I audible?
Yes, sir.
Huh. So it has to lose 1 electron, so it has to form a bromine molecule, so you'll multiply it by 2. So 2 bromide ions lose 2 electrons and form Br2. So what is releasing at the anode? Bromine. Bromine is very reactive, and at 380 degrees Celsius, it will be in the form of fumes. So if you take platinum, so platinum may react with bromine vapors, whereas graphite is unaffected by reactive bromine vapors. Hence, we use graphite as an electrode over platinum. Okay. Observations at the anode, you have to write the observation: dark reddish brown fumes. Don't write liquid, because of 380 degrees Celsius, it will be in the form of fume. And observation at the cathode will be silvery gray metal deposited. Silvery gray metal deposited. I think in your question paper, prelim 1, they have asked a question: name the product formed at the cathode. So many of you written lead and you lost the marks, right? What they told, you have to write pure lead, है ना? So keep following that. So if they ask you what is the name of the product formed at the cathode, pure lead. And similarly, write what is the name of the compound substance formed at the anode, pure bromine. Okay. Any doubt in this?
Sir, that reaction starts.
Reactions.
Through the gain and loss in the
Always cation, no, it want to become an atom. Matlab it has to gain electrons. Okay, gain of electron means reduction. See, plus 2 means what? It is having 2 electrons less. Means it needs 2 more electrons to become an atom. So here the 2 electrons it will gain. But whereas bromide, it has excess of electron, therefore it has a negative ion. So it will undergo oxidation at the anode. Where oxidation takes place? CNR POW. POW means positive anode oxidation. So at the anode, oxidation takes place. So it will lose the electron. One more rule we should know here: number of electrons at anode should be equal to number of electrons at cathode. So how many electrons are involved in the anode? 2 electrons. Same number of electrons should be involved at the cathode also. That is 2 electrons. Why? Because the electrons lost at anode, same electrons will come to the cathode, and that will be gained by the positive ions. These electrons will not come from anywhere. It is actually transferred from the anion to the cation through the electrodes. Okay. Therefore, how many electrons anion loses? Same number of electrons cation will gain. So this is a rule you have to remember. And whenever they ask you to write both the reactions, you have to make the number of electrons equal at anode and cathode.
yes, sir.
Correct. So many of you, if you see second option also, a silver gray deposit at cathode and a reddish brown deposit at anode. No, it is not a deposit. Okay, it's a fumes. Therefore, second option is not correct. Okay. Isha, can you tell the answer?
Um, Copper which liberates reddish brown gas around the anode during electrolysis molten state is lead to bromide.
Yes. Because reddish brown gas, there are only two things: bromine gas, or NO2 gas. But in electrolysis, we don't get NO2 gas in any of our examples. Therefore, that we should not take. But any other example of bromide, instead of lead bromide, if they have given here zinc bromide, then also you have to select that option only. Okay, next one, Dhanish. So option number 4. Okay, here give appropriate scientific reasons for the following statements. During electrolysis of molten lead bromide, graphite anode is preferred to other electrodes. Chanvi, can you tell me the reason?
So first, because the electrodes are inert, because they shouldn't take part in the reaction,
Hmm.
and because graphite's not affected by the reactive bromine vapors.
Right. So in this case, at the anode, we know the bromine vapors will be released, and we have to select such an electrode which is not get affected by that. So graphite is unaffected by reactive bromine vapors released at anode. Specifically, they have asked here anode. Electrolysis of molten lead bromide is considered to be a redox reaction. Um, Tell me, Dhruva, what is the reason for this?
So electrolysis of molten lead bromide is considered to be a redox reaction because uh, at cathode reduction takes place and at anode oxidation takes place, therefore considered to be a redox reaction.
Okay, fine. Not only this, if they ask you any question, electrolysis of acidified water, lead bromide, copper sulfate, anything, always we will
Yes,
write
same.
same answer. So at the cathode, reduction is taking place, and at the same time, at the anode, oxidation will be taking place. Hence, all of them will be redox reactions. Correct the following statement. For example, chlorine is a bleaching agent, so you have to add the word moist. Chlorine is a bleaching agent. Lead bromide conducts electricity. So what we have to add here? Iona?
Thermo.
No, no.
Sorry.
Iona?
Yes, sir. One second.
Hmm.
Sorry, there's a fleeting again.
Missing word.
Molten.
Yeah. So we can add the word molten lead bromide or fused lead bromide. Okay, coming to the second example of electrolysis, acidified water. So the reason why we use acidified water, we know already. Pure water is a non-conductor of electricity because it has no free ions. To make it conductor of electricity, what we do? We add a little bit of sulfuric acid into it. So here sulfuric acid will act as a catalyst. How? It will ionize the water and speeds up the reaction. Hence, this reaction is also considered as catalysis. Okay. Here the electrolyte we are using water which is acidified with dilute sulfuric acid, or you can simply write acidified water. And the electrolyte, not electrolyte, electrolytic cell what we use, it has a specific kind of apparatus that is called as Hoffman's voltameter. Voltameter is nothing but electrolytic cell only, but if you write voltmeter, that is different. Okay, voltmeter will be for different to measure the voltage, but the potential difference, but this one is for electrolysis. And the electrodes, again here we are using inert, that is platinum electrodes we are using. Okay, observe here what you have in the electrolyte. Water we have, sulfuric acid, even though small amount, but it is there. The water will give H plus, OH minus. Sulfuric acid H plus, SO4 minus 2 and 2H plus here. So there is no competition for H plus. So understood, H plus will go towards the cathode and get discharged as hydrogen. And between hydroxide and sulfate, hydroxide will get preferentially discharged because Suno caliber IO, lower hydroxide. Sulfate is on the top. Okay. Now, cathode reaction. Before that, let's write anode reaction. Anode is positive. Positive may negative ion will go. Negative here is OH minus. This reaction has been asked many times. So it has one extra electron that it will lose and becomes OH. But OH is not any atom or not a molecule. It has no meaning. It does not exist. So what it does, one OH will combine with another OH and forms H2O plus O. You can see H2O plus O. But oxygen atom is not stable. So one oxygen atom will combine with another oxygen atom and forms O2. So to get two oxygen atoms, what you have to do? Second equation you have to multiply by 2. Then what happens? 2 OH plus 2H. 4 OH you need. To get the 4 OH, what you have to do? First equation you have to multiply by 4. But I don't want to do all of this. I just want to write the final equation. Then you simply take 4 OH minus, lose 4 electron and forms 2H2O plus O2. Okay. Or if your teacher accepts second part 4OH gives you 2H2O plus O2, that also you can write. But this one, I want you to practice this one. 4 OH minus lose 4 electron and forms 2H2O plus O2. Now how many electrons are involved here? 4 electrons. Same number of electrons should be there at the cathode as well. Cathode is negatively charged, cation is H plus, but one H plus can gain only one electron, right? Because only one electron it requires. But you want to make 4 electrons, so what do? Multiply this by 4. So 4H plus 4 electrons will give you 4 hydrogen atom, but it can form 2 hydrogen molecule, right? 4 hydrogen atom will give you 2 hydrogen molecule. Hence, you observe here at anode you are getting 1 volume of O2 for every 2 volumes of hydrogen which is released at the cathode. 2 volume, here 1 volume. You can get this ratio only if you make the number of electrons equal. Otherwise, you will not get it. Therefore, what is the ratio between the volumes? By volume. Hydrogen is to oxygen. 2 is to 1. Okay. So, this is the thing. Ratio of hydrogen to oxygen is 2 is to 1 by volumes. Sometimes they ask you, give reason for this. Why the ratio of hydrogen to oxygen is 2 is to 1 by volume during the electrolysis of acidified water. Okay. This one you may not get anywhere. So write it if you want. You have to use the Avogadro's law here. Yesterday we have learned Avogadro's law. What is that? Anybody remembers? What is Avogadro's law? Equal volumes of all the gases contain equal number of molecules at the same temperature and pressure. If the volume of the gas is same, then the number of molecules are also same. Here you have to connect it in reverse. So here what is happening at the cathode? 2 molecules of hydrogen are formed, for every 1 molecule of oxygen at the anode. So reverse is also true. If equal volume contain equal number of molecules, then equal number of molecules will also contain equal number of volume, right? Therefore, you have to explain it based on Avogadro's law. As per Avogadro's law, same number of molecules for any two gases contain what? Same number of volumes, provided you are measuring them at same temperature and pressure, right? Therefore, for every two molecules of hydrogen formed at cathode, one molecule of oxygen formed at anode. Therefore, the ratio between volumes is 2 is to 1 for hydrogen is to oxygen. Okay, so this is how we have to explain if they ask the reason for this. Sure. Okay, Darshana, can you tell the answer?
So, B, I think.
Electrolysis of acidified water is an example of oxidation.
Sir, I'm not sure. I get confused.
Array, we just told you many times, no? Every electrolysis is an example of redox, right? Why? CNR power, what I told, at cathode reduction takes place, at anode oxidation takes place always. So they always take place simultaneously. Not only this, any electrolysis. Okay.
Yes, sir.
Vanishik.
Yeah.
Okay. So you can also write here total acidity at the anode and cathode is unaffected, because in this whole process only water get decomposed. Okay, and nothing will happen to the concentration of H plus coming from the acid. Hence the total acidic nature will remain as it is, and this will be an example of acetylate catalysis. Okay. Okay, third example, aqueous copper sulfate solution. So before we do this, we'll take 5 minutes.
Sir, can you go back to the previous slides for like a minute?
Yeah.
Yeah.
So we'll take a 5 minutes break here. Okay, 11:05 we will come back. Okay, let's continue. The next example is electrolysis of aqueous copper sulfate solution. So here we have two cases. Basically talking about only anode. In one case we use active anode, in another case we use inert anode. Inert anode may be the platinum or the graphite, and the active anode is copper itself. So what changes here is the product at the anode, that one thing will change. Another one will be the color of the electrolyte, that will change. Okay, or the observation will be different. But the reaction at the cathode will remain same for both. Okay, so here aqueous copper sulfate solution. So here the electrolyte will be that one only, saturated copper sulfate solution. Then we take a glass beaker, you can say. Voltameter is nothing but electrolytic cell. So glass beaker we can take as electrolytic cell. In the first example or first case, platinum anode means we are taking the inert anode. Cathode doesn't matter whether you take inert cathode or you take active cathode, that doesn't matter. Only what matters is about anode. Okay, so here what happens when copper sulfate in aqueous state, right? It will form copper ions, sulfate ions, and water always give you H plus, OH minus. And according to the preferential discharge chart, copper and H plus, if you compare, copper is below, so that will preferentially get discharged. And between sulfate and hydroxide, hydroxide is below, that will get preferentially discharged. This is case number 1, where we are using inert anode. Inert is, it may be platinum, mainly platinum we use, or we can also use graphite. In that case, what happens? I'm writing the reaction at the anode. So anion is OH minus. OH minus, previously we have seen the oxygen release. So same, I'm writing it directly now. 4 OH minus minus 4 electrons will give you 2 H2O plus O2. And the reaction at anode is positive, right? And the reaction at cathode, which is negative, cation will come. Cation here will be copper. So copper plus 2 will gain 2 electrons. Plus 2 means it can gain 2 electrons and form copper. But to make the number of electrons equal at anode and cathode, what you have to do? Multiply this by 2. So you will get 2 copper plus 2 plus 4 electrons will give you 2 copper atoms. But if they simply ask you what is the reaction at the cathode and do not ask you the reaction at anode, you can just write the first part. Copper 2 plus 2 electrons gives you copper. That much will be enough. But whenever they ask you to write both, then you have to make the number of electrons equal. So this is case 1. Case 2, where we will use active anode. Active anode means we are using the copper electrode itself. Copper conducts electricity and takes part in the reaction. So copper electrode. Now cathode reaction remains same, but anode reaction will change. Why it will change? Now towards anode, what will come? The anions. Anions are which one? Sulfate and hydroxide. But copper is being active electrode that also want to take part in the reaction. So that will also compete with the hydroxide and sulfate. So compared to anions, metals always lose electrons better, right? So at the anode, oxidation takes place, right? So metal will win in this case, not the hydroxide, not the sulfate. The copper itself will take part in the reaction. It loses 2 electrons and forms copper plus 2 at the anode. But the reaction at the cathode remains same because there is no competition for cathode cations. So here copper 2 plus 2 electrons become copper. Okay. This is the difference between the inert and active. See, second case, what is happening? This is the one. You are taking here copper, here also copper. Okay, anode and cathode. So this copper will dissolve, anode will dissolve in water, sorry, in the electrolyte and forms copper 2 plus. That copper 2 plus will come where? It will come and deposit on the cathode, right? It's forming back copper. So basically you can say anode dissolves and that copper comes and deposits on the cathode. From anode to cathode there is a movement, but in that process it has to get converted into copper ions, and that copper ions has to get converted into again copper metal atom. Okay, therefore the observations also will be different for them. In case of first case, that is when you use inert anode, reddish brown or pink metal deposited at cathode. Cathode observation will not change. Copper metal depositing, so you have to write reddish brown or pink metal for copper. Second one, for the color of the electrolyte, when you talk, the blue color of the electrolyte solution fades away. The reason is due to decrease in copper 2 plus ions in solution. See, when you're taking inert anode now, all the copper 2 plus ions which is responsible for the blue color of the solution, it is get converted into copper, and there are no reaction forming back the copper ions. Hence, the blue color fades away if you take inert anode. But if you take active anode, what happens to the blue color of the solution? It remains blue only. That's because at the cathode, copper 2 plus ions are used up, but at the same time, what is happening at the anode? They are forming back. So copper 2 plus gone, but copper 2 plus came back. Therefore, the color of the solution will not change when you use the active anode, or copper electrodes. And talking about the observation at the anode, you can write anode diminishes in mass and size. Diminishes in mass and size. Okay. This is only for active. Second case. Okay. In first case, what you have to write? Oxygen gas. Test for oxygen you have to write. If they ask you what is the observation at the anode when you use the platinum anode, oxygen gas test you have to write. A colorless, odorless gas released which rekindles a glowing splint. Okay, there you don't write diminishes in mass and size. That will not happen. That will happen only if you are taking copper electrodes. You should not write the names when they ask you the observations. Write only at the anode reddish brown fumes are formed, and at the cathode silvery gray metal deposited. Do not write lead and bromine. If they ask you name the products, then only you have to write that. Okay.
Yeah.
Whenever they ask you observations, remember children, don't write the names. You have to write the color change, precipitate color, any gas test, that you have to write. So cathode cation is okay, silvery gray metal deposited, and here reddish brown fumes observed. Okay. Danish, can you hear me?
Yes, sir.
Can you tell me the answer for second one?
Uh, so the solution will remain blue even after the test. Like they can't really remain blue.
If you
And
write that, that will be incorrect because they have asked the observation at anode and cathode and not about the electrolyte solution color, right?
then at the cathode, we can see deposition of a pinkish metal, which is copper, and at the anode, we can see the anode diminishes in mass because it releases copper ions into the solution.
Hmm. So simply we can write pink metal deposited, anode diminishes in mass and size. Don't write anything else. And if they ask you write the observation with respect to the color of the electrolyte, then you have to say the color of the electrolyte will remain blue only. Okay. Hmm. Isha,
Yes, sir.
can you read?
Write equation for the reaction taking place with the two electrodes.
Hmm.
It will be
So two electrodes are which one?
anode and cathode.
Right. Anode is positive, cathode is negative, है ना?
Yeah.
So we are taking copper sulfate with copper electrodes. Copper electrode is active electrode.
Yeah.
Hmm.
So at the anode, it will be Cu minus electrons gives Cu to the,
Right.
and then at the cathode it will be Cu2 plus plus 2 electrons gives Cu, and the whole thing times 2.
Correct. Very good. Okay. Vanishika, B part.
Yes, so Br2 minus 2 electrons.
Br2 you will take directly. Anion you have to take, na? Molten lead bromide. What anion it will have? If you are having confusion, just write this. Lead ion will form, bromide ion will form, not bromine. Right? Two bromide
So,
ions you take. Huh? One
so
bromide can
minus
lose one electron. Two can lose two electrons. And it will form what?
Br2.
Yes. See, always the neutral substance you will get after the reaction. That's why it is called as discharge. What is the meaning of discharge? Whatever charge is there, that has been removed. Okay. Okay. So here, cathode reaction, what will happen?
Pb2 plus 2 electron gives P.
Correct. Okay. Fine. So you people having confusion means you keep on practicing this. Okay. If you want to avoid the confusion and understand, basically you have to understand the concepts. And if you want to know, if you try to remember, then it's very difficult. You will definitely have confusion. Okay. Name the metallic ions that should be present in the electrolyte when an article made of copper is to be electroplated with silver. Okay, this question has been asked many times. This is the next concept we're learning, that is electroplating. But Aryan, can you tell me the answer for this?
Sodium, sorry, aqueous sodium magenta cyanide solution.
Okay, can you read the question once again?
Name the metal. Oh, okay. Ag plus.
Name?
Silver ion.
Mm, right?
I just read the electrolyte. That's why.
That's what you do. Don't do that. Okay, silver ions. So the one which we want to electroplate, that ion should be there. Okay. State one relevant observation at anode aqueous copper sulfate solution electrolyzing copper electrodes. Remember, this has been asked many times. Copper electrodes, this thing. Okay. So anode, what happens? Diminishes in mass and size, right? And here at the cathode, they have asked. So cathode, pink metal deposits, which we have already written. During the electrolysis of copper to sulfate solution using platinum as cathode and carbon as anode. So again, carbon is nothing but graphite. Graphite is also inert. So whenever inert, this is case number one. What do you observe at the cathode? Pink metal deposited. This is same. In both the cases, pink metal deposited. But at the anode, do not write diminishes in mass and size. Okay. Dhruva, who is that unmuted? Please mute yourself. Anode will be, what will happen here? Anode, tell me, Rohani. What will release at anode when you take inert electrode?
When we take inert electrode, OH1 minus ions are discharged.
Product. What is the product? When hydroxide ion?
So colorless gas.
Hmm.
Oh, oxygen.
Oxygen
Oxygen
gas.
filled.
Oxygen gas के लिए you have to write the test. Don't write the product.
Oh,
So here.
colorless gas that rekindles a glowing spark.
Hmm. Okay. See, whenever hydroxide ion get discharged, it will always form oxygen gas. 4OH, 4 electron, 2H2O plus O2. So you have to write the test for O2. Colorless, odorless gas which rekindles a glowing splint. Okay. What change is noticed in the electrolyte? Darshwana?
Sir, blue solution remains blue.
Okay. If it has to remain blue. Hmm.
Sir, it doesn't remain blue. Sorry, I got confused. The blue becomes colorless because it's inert.
Right. Blue color of the electrolyte fades away. See, we should understand why it is blue, because of copper ions. And what is happening to copper ions? They are converted into copper. Therefore, there are no more copper ions, matlab there is no more blue color. When? In case of inert. Write the reaction at the cathode and anode. Anode reaction I have written here. Cathode reaction is copper carrying two electrons, copper. But you have to make the number of things equal. So 2 I have to make. 2, 4, 2. Number of electrons will be same. Okay. Again, based on copper sulfate solution only. Diagram questions. Which electrode to your left or right is known as the oxidizing electrode and why? Who will tell me? Raise your hand.
Anode is oxidizing electrode.
Left or right?
Left.
Left. So because this is positive, this is negative. So left anode, CNR POW. Okay, POW means positive anode oxidation. Why? Why it is oxidizing electrode?
Because it's losing percent.
Oxidation takes place.
Yeah.
Oxidation takes place. Oxidation is what? Loss of
Loss of
electron. Yes. So here anions will come and lose electron. Hence they undergo oxidation. Therefore the electrode will be oxidizing. Okay. Write the equation representing the reaction that occurs. State to appropriate observations for the above electrolysis reaction. Okay. So again, equation, but here they didn't mention where. Write the equation representing the reaction that occurs. Okay, so study the diagram given below and answer the question copper electrodes. So what do? You write both the reactions. Okay. Otherwise, maybe it is connected to first part. We are not sure about it.
yes.
If it is only for anode, then we will write only copper loses to electron and copper to plus. But you know this is simple equation, so write both. Anode and cathode you mention and write both. State to appropriate observation. Again, same thing. Anode diminishes in mass and size. Cathode, pink metal deposits. Okay. Okay. Iona, what is the word or phrase? Electroplating. Whatever we studied, the second case for copper sulfate using active electrode, the same technique we use to do electroplating as well as electro refining, which are the applications. If they ask you what are the two applications of electrolysis, you can write electroplating and electro refining. Okay, now so electroplating is the one where basically it is used for decorative purposes. We have some metal, on top of that we will deposit some superior metal like silver or nickel or something, okay, so that it can look better. That will be the electroplating. Here we have two examples. First example is electroplating with silver. We use sodium argentocyanide solution. If you don't write the solution, then it is not correct. Okay. In always electroplating, say I want, there is some spoon here. Okay. That spoon I want, it is a, which color? Steel one. I want it look like a silvered color spoon. So what you have to take? Always we know metal will come and deposit on the cathode. Always metal will come and deposit on the cathode. So you have to take cathode as that spoon. The material or the article to be electroplated you have to take as a cathode, and anode should be your desired metal which you want to deposit on the spoon, and your electrolyte should be the one which contain the metal which you want to deposit. In this case it should be the one which contains silver ions, that is sodium argentocyanide solution. Argento means argentum. Ag for argentum is nothing but silver. Sodium is there. Cyanide is Cn minus. Cn minus ion is called as cyanide. This kind of compound we call it as a complex compound. So when you put it into water, it dissolves slowly or decomposes slowly into ions, Na plus, Ag plus, and Cn minus ions. Okay, you can see it here. Now the reaction is same. You are using active anode here also, no? You're not taking platinum, you're not taking graphite, matlab you're taking active anode. Therefore, the anode itself will take part in the reaction, and that will come and deposit on the cathode. The reactions are simple. Ag loses one electron and becomes Ag plus. That Ag plus comes to cathode and gains back that electron and becomes again silver. So basically you are depositing silver on the surface only. You can't deposit, you can't put it inside. It is only on the surface of the article you are plating it. Therefore it's called as electroplating. So here one give reason question given. Why don't we use silver nitrate as a electrolyte? Why we are using this sodium argento cyanide solution, right? So if we use silver nitrate, what happens? The electrolyte then deposition of silver will be very fast, hence not smooth and uniform. Okay, because it is mainly done for decorative purpose. The article should look very nice. If the deposition is not smooth and uniform, then it will be waste, right? Therefore we use sodium argento cyanide. One more question has been asked for how you can make this deposition smooth and uniform. We have to use low DC direct current for a longer period of time. This will make the deposition smooth and uniform. One condition, if they ask you, you can write this condition. Low direct current for a longer period of time. Okay, questions on this? Aryan?
Yes, sir. Third one.
Okay. Chanvi?
So the electrolyte is sodium argento cyanide.
That will be wrong.
Solutions, accuracy.
Even if you write sodium argento cyanide in exam, no marks. You have to write the aqueous solution. Hmm? The electrolyte sodium argento cyanide is preferred over silver nitrate. We have just discussed about it. During the silver plating of an article using potassium argento cyanide, instead of sodium, we can always use potassium for anything. Okay, na? As an electrolyte, the anode material should be. So if you are doing silver plating, then the anode should be silver only. Okay.
So,
Uh,
so,
hmm.
so you were saying, you said something about nickel, right? I missed it on the.
Nickel. Nickel will come next part.
Sorry. So you said direct current and AC current, and I got caught that time. So I mean,
So if you want to make the deposit smooth and uniform, what is the condition? We have to use low direct current for a longer time. Okay.
yeah.
Hmm.
Okay.
Uh, this is done. This is done. Okay. See here this question. A metal article is to be electroplated with silver. The electrolyte selected is sodium argento cyanide. What kind of salt is sodium argento cyanide? So if they ask you this question, you can write it is a complex salt. Okay, we have different kinds of salt, not only acid, normal or basic salt. Other kinds of salts are there. Simple salt, complex salts, double salts. Okay, so it's a complex salt we can write. Why is it preferred to silver nitrate? Again, right, silver nitrate if you use, it is not smooth and uniform. One condition to ensure that the deposit is smooth, again, the same answer, low DC, longer time. Write the reaction taking place at the cathode. Cathode means cation, cation is Ag plus. gains the electron and becomes Ag. Reaction takes place at the anode. Anode itself will take part in the reaction and becomes Ag plus. Okay. Second example is electroplating with nickel. Same. The article to be electroplated should be taken as cathode, and pure nickel you have to take as anode. This one point again you write, if they ask you what you are taking as anode, you write pure silver, pure nickel. Hmm? That part. And what is the electrolyte? Aqueous nickel sulfate solution. Aqueous nickel sulfate solution. Same thing happens here. Anode. Anode is nickel. Nickel itself will take part in the reaction. So its valence is 2, so it loses 2 electrons and forms nickel ions. And at the cathode, the 2 nickel ions only will gain 2 electrons and form nickel atom. Okay. Same thing. Here, no give reason questions, nothing. Aqueous solution of nickel sulfate contains nickel and sulfate ions. Which ion move towards the cathode? What is the product at the anode? So cathode में cation will move. Cation is nickel ion. Product at the anode. Anode में don't write sulfate. Anode product will be nickel ion only. How? Anode, what reaction takes place? Nickel minus 2 electrons gives you nickel ions. These are the products, na? Correct? Chalo. Keychain with nickel, same thing. Okay. Electro refining of copper. This is the second application. So again, whatever you learned, copper sulfate electrolysis using copper electrodes, it is same. But only that you are using here to purify the impure copper. Okay. So what do we do here? Cathode, we know where the metal will come and deposit. It will come and deposit on the cathode. So your cathode should be pure and it should be thin, because once the metal deposits, it becomes thicker and thicker. So you have to write thin sheet of pure copper. We are taking as a cathode, and anode will be your impure copper. And anode, what happens? It diminishes in mass and size. Therefore, initially you take it thick, so it decreases in mass and size. Therefore, cathode will be thin. It increases in mass and size. Okay, so this logic you have to understand. Don't try to remember. Okay, so try, if you try to remember, then it is difficult. Thick block of impure copper, thin sheet of pure copper. So this is your electrolyte. This is your anode. Say this thin sheet will be cathode. So positive, negative. And always your electrolyte must contain copper ion. So here it is copper sulfate solution. And the reactions are same. This copper, it will itself will take part in the reaction and becomes copper 2 plus ion. Yes, Rishi.
Sir, can copper also be electroplated?
This is not electroplating, it is electro refining.
No, but can it also be used for electroplating also? Copper.
It can be done, but usually we don't do that because copper is not so rich element. No,
Hmm.
two purposes we do electroplating. One, it may be used to stop the corrosion of the metal, and another one is for decorative purpose. Like gold, we can do, silver, we can do, because they look rich. Okay, so this is the reaction at the anode. This is the reaction at the cathode. So what happens here? This will diminish in mass and size. It becomes thin and thin, and this one will become thicker. Okay. In this process, we are purifying it. Means some impurity should be there now. So you can see here. Some metals like silver and gold remain insoluble and get collected at anode. So means it will form some impurity here. And that impurity we call as anode mud. It is near anode. So what is that impurity? It may be some silver and gold particles. Later they will extract that also. Okay, so this is simply the same what we learned for copper electrodes and copper sulfate reaction. Lastly, we'll see some questions. Copy and complete the table, anode and electrolyte, purification of copper. Okay. Yes, Ruhani, tell me what anode we will use here.
Impure block of copper.
Hmm. And what will be the electrolyte?
Aqueous copper sulfate solution.
Yes. So we will take thick block of, है ना? Thick block of impure copper, and electrolyte will be aqueous copper sulfate solution. A reaction taking place at the anode. Anode will be copper itself will lose two electrons and become copper ions. 2023 question. Dhanish.
Yes, so fill in the blank by using electrons during analysis of compound. Second one, PBR.
Okay. Second one. B.
Reactions check. Reactions
Copper 2 plus ions. Okay.
discharge.
Uh, Darshwana, can you read the question, please?
Yes, sir. Choose the correct word which refers to the process of electrolysis from A to E to match the description from 1 to 4.
So these are some words they have given. You have to match only these with four options. Okay. So what will be the answer for the first one?
So should I D, an electrolyte?
D, an electrolyte conducts electricity. Yes. Very good. Vanishika, what will be the answer for second one?
Sir, oxidation?
Oxidation. A, correct. Rohani, what will be the third one?
Sir, cathode.
Cathode, right. Aryan, what is the last one?
It's anode.
Anode, C. Yes. Okay, so this is also asked in 2023 only. Huh. See, an aqueous solution of nickel 2 sulfate was electrolyzed using nickel electrodes. Observe the diagram and answer the questions. Nickel cathode, nickel anode. Aqueous nickel sulfate. What do you observe at the cathode and anode respectively? So here we can say here anode what is happening, nickel is coming and depositing cathode mein, anode mein nickel is getting dissolved. So you simply write for cathode increases in mass and size. Anode diminishes in mass and size. Okay, both the points you have to write. Don't write only one. Name the cation that remains as a spectator ion. Now, what is the spectator ion? There are some ions which are there in the electrolyte solution, but they are not taking part. They are just there in the solution. Such ions we call as spectator ions. So when you take nickel sulfate solution, aqueous, so nickel sulfate will form nickel ion, है ना, sulfate ion, and water will form H plus OH minus. Now only they have asked here name the cation. So anyway, nickel is taking part in the reaction, so that is not a spectator ion.
H plus.
It should be hydrogen ion. You have to name hydrogen ion. If they ask you name the anion that remains as a spectator, so here two anions are there. You can write both of them, hydroxide as well as sulfate. Both are not taking part. So both of them are spectator ions. Okay. Last one. Chanvi, tell me what is the correct answer for last one?
Which of the following reaction for the anode?
Anode is correct. Hmm?
minus. So it's the third one. Sorry, third.
Third one, nickel ions.
First one.
See here, first of all, you know the reaction at the anode, Chanvi. What you will write if I ask you to write the reaction at anode here?
I'll write that it's like gaining 2 electrons.
Anode, anion will come. Okay, here nickel itself will take part. So how it will gain?
Oh, okay.
Nickel loses 2 electrons, na? Loss of
Yeah.
oxygen, anode, CNR, POW, oxidation.
Yeah.
But what they
Yeah.
did here, they sent these 2 electron right hand side. So what happens then? It will become plus,
Yeah. Yeah. Okay,
right?
I got confused.
Therefore, whenever you have confusion, just write your what you know already. Then you
I'm
try to
writing
match
it.
it. Okay. So nickel will give you nickel ions and 2 electrons. Sometimes these kind of changes they will do. Okay. Some questions like this. This one we have already seen. Name the particles. Strong electrolyte, you have to write only ions or mainly ions. Non-electrolyte, only molecules. Weak electrolytes, ions and molecules. Right? Ions and molecules. Ionic or electrovalent compound do not conduct electricity in their solid state. Electrolysis of aqueous sodium chloride solution. This one, this one, this one. Okay, Vanishika, tell me what is the answer for this?
Electrolysis of aqueous sodium chloride solution will form sodium metal or calcium.
What I told you, remember? Sodium metal you will never get if there is water.
Yes.
Hmm?
Yes. Hydration.
Huh. Sodium metal when you will get if it is in the molten state, whatever substance you are there taking, only if it is in molten state you will get sodium metal. Instead of they are giving aqueous, if they given fused, then sodium is correct. Okay, otherwise
Okay.
it is incorrect. ठीक है, चलो. Okay, these are again different kind of questions. Chloride ion to chlorine molecule. Again, what you people do, silly mistakes you do. Hmm? Chloride ion is what? Cl minus. Chlorine molecule is what? Cl2. What you people do? Cl minus loses 1 electron and Cl. This much only you will write. Where is chlorine molecule? Right? So to make it, you have to take 2 chloride ions, lose 2 electrons and form chlorine molecule. Hmm? That will be the answer for that. Second one. So here it is loss of electron, oxidation. You know, oxidation is the loss of electron. Third part. Lead 2 ion to lead. So lead 2 ion is Pb plus 2. Say lead. So it should gain 2 electrons. And it is gaining of electron reduction. Okay. Hmm. Ruhani, tell me the answer for second one. Yep, this one.
Yes, right. The electrolyte used for electroplating an article with silver. This is aqueous solution of sodium argentocyanide.
Hmm. Good. Sodium argentocyanide. Okay, the particles present in liquids such as kerosene. Dhanesh, Dhruva,
So molecules.
right. Because kerosene is a non-electrolyte, it's only molecules. Last question. Observations. Again, I think we have already discussed it. Observation at anode and cathode. Matlab, you have to write them separately. You have to mention at anode, at cathode. Do not just write reddish brown fumes, silvery gray metal. At what electrode, what is the observation? Clearly how to mention. Okay. Copper sulfate is in copper electrodes. Anode diminishes in mass and size, and pink metal deposits at the cathode. Select the ion in each case that would get selectively discharged from the aqueous mixture of the ions listed below. Rishi, tell me what is the answer for first one?
First one, select the ion in each case and sir, that's OH.
OH minus.
OH minus.
Okay. Chanvi, what is the second one?
Um, so AG.
Hmm. AG. Sometimes they may also ask you to arrange them in the decreasing or increasing order, just like they give for periodic table questions.